In today's lesson, we are exploring types of discontinuities. It's kind of a nice lesson because it's all review from last year from pre-calculus. So the idea of a discontinuity, it's the places in a graph that stop continuity, that stop the graph from being continuous. So the three types are jump discontinuity, essential discontinuity, and removable discontinuity. And then there's some other words that we use for all three of these. A jump discontinuity is when there's a break in the graph, and we often see that with our piecewise functions. So here is an example of a piecewise function where we have, one linear function, and then it breaks and we jump up to like the next part of the linear function. So this will be that jump discontinuity because you are jumping your graphs. The next type of discontinuity is the essential discontinuity, which we also refer to as the infinite discontinuity, and this is when we have a vertical asymptote. So here's an example of a rational function. This denominator cannot be equal to 0, so what value creates a 0? Positive 2. So this is where we have a vertical asymptote at positive 2. And now the last type, a removable discontinuity, this is where we have a hole in the graph. So here is the example. I just have it in factored form. So for your lesson, you're going to actually have to factor it. So when it's in factored form, we can see that if two factors cancel out, so this denominator, instead of creating a vertical asymptote, it creates a hole. So this function simplifies to just x minus 4. That's just a linear function, but then the idea is that at -3, there's a hole. So here's our first example. We want to determine the type of discontinuity and where the discontinuities occur. So anytime you see a quadratic over another quadratic, you all know what I'm going to say, you need to think about factoring both of them. So the numerator will factor 2x minus 5 and x minus 3. Denominator is going to factor x minus 5 and x minus 1. So notice how these factors cancel. Where it cancels, that automatically means that we have a hole at x equals 5. But here, I still have x minus 3 over x minus 1, so I still have that variable in the denominator. So I will still have also a vertical asymptote at x equals 1. So type of discontinuity and where it occurs. Okay, here's the next example. This time there's nothing to factor. So there's no factoring and canceling. We just have to deal with the fact that we have this in the denominator. So 3x plus 5 cannot be equal to 0. So let's solve for x and decide what x value creates the 0. Well, that would be at -5/3, and that means that there is a vertical asymptote at -5/3. So these questions are not too bad at all. Until now, and I make you do some trig. So the last example is cosecant of 2x, and we're going to only consider this with a domain from 0 to 2 pi. So we're trying to find discontinuity. So why would this graph have a discontinuity? Well, f of x, so cosecant can be rewritten as 1 over sine of 2x. And now that we have this denominator, we know that the denominator, sine of 2x, cannot be equal to 0. So when is sine 0? Sine is 0 at 0 and pi, and then also at 2 pi. But what I want to do is notice how we have this restricted domain. We're only considering x values from 0 to 2 pi. But now in this function, we have 2x. So I'm going to multiply my domain everything by 2. So now I'm looking at 2x. I'm looking at the domain from 0 to now 4 pi. So this 2x inside cannot be equal to 0 because at 0, sine is 0. And this 2x cannot be equal to pi. 2x cannot be equal to 2 pi. 2x cannot be equal to 3 pi. And 2x cannot be equal to 4 pi. So now, essentially, we're just solving by x, or solving for x. So where are these vertical asymptotes? So instead of using the do not equal sign, I'm using the equal sign because that's where the vertical asymptotes are happening. So there's a vertical asymptote at x equals 0 and a vertical asymptote at x equals pi over 2, at pi, at 3 pi over 2, and 2 pi. And now here is the actual graph of cosecant of 2x. So just to kind of give you a memory of what the cosecant graph actually does look like. And here's all of the asymptotes. So we've got the 0, pi over 2, pi, 3 pi over 2, 2 pi. So there is your full video on exploring types of discontinuities. Good luck with the lesson.